In today's lesson, we're going to continue with our elementary differentiation rules, which is section 4.5 of our textbook. We have two rules that we're going to look at. One is called the sum rule and one is called the difference rule. And basically they are the same thing, except in one we are adding terms together, and in another one we are subtracting terms together. And basically what they are saying, if function f and function g are both differentiable, and y is the sum of function f and function g, to take the derivative of y, we take the derivative of my f term, keep the sign the same in between, and take the derivative of the g term. Same thing if we're subtracting, the derivative of the f term minus the derivative of the g term. Now this will make a lot more sense once we see a specific example. In our first example, we'll just start over here. Say we have f of x is equal to 9x to the 8th minus 8x to the 7th plus 4 to the 5th. I have a total of 3 terms being added or subtracted together. To take the derivative, all I'm going to do is take the derivative of each term using the rules we learned in our previous lesson. So the derivative of 9x to the 8th, the 8 comes out front, it would be 72, subtract 1 from the exponent would be 72x to the 7th. I bring the 7 out front, and that's going to become 56x raised to the power of 6. The last term, which is 4 to the 5th, is a constant, and the derivative of a constant is 0. So that would be my derivative. Let's take a look at another example. Right now, we have a product of two terms. So the first thing I need to do is I have to multiply these together to get it as a sum and difference of terms. So I'm back to multiplying binomials. I'm going to get x squared plus 3x minus 4x, subtract 12. Collect like terms here. I have x squared minus x minus 12, and now I have it as a sum or difference of terms, and I take the derivative of each term. So f prime of x is going to equal 2x, subtract. Now be careful, this is x to the first. I bring the 1 out front. It's going to be 1, x to the 0, which is 1, so my final derivative is simply f prime of x is 2x minus 1. Many students struggle when they're asked to take the derivative of a constant times x, and the key thing to remember with that is, for example, if I have 3x, the derivative of that is simply, well, hang on, let me just erase that, sorry. If I have 3x raised to the power of, say, 1, which I'm trying to do here, okay, so if I have 3x raised to the power of 1, again, bring the 1 out front. 1 times 3 would be 3. That would really be x to the 0, and x to the 0 is 1. So my derivative is 3. So anytime we have a constant times x to the first, the derivative ends up being just your constant. Okay, let's take a look at this one. Now, in the last lesson, we had to get rid of any radical and change it to a power of 1/2 or 1/3 depending on the index. Well, here my index is 2 in both cases, so the first thing I'm going to do is I'm going to rewrite this as follows. So I have f of x is going to equal, this is really the square root of x divided by the square root of 3 minus 2, and if I rewrite x as a fractional exponent, it's going to be 1/2, and I still have my constant of 6. Now I'm going to rewrite my numerator of my first term as a fractional exponent. So that's going to be x to the 1/2 still over the square root of 3 minus 2. If I move x to the 1/2 to the top, it becomes negative 1/2, and I have plus 6. Just to simplify this a little bit more, this root 3, which is in the denominator, could really be considered a coefficient of 1 over root 3, x to the 1/2 minus 2x to the negative 1/2 plus 6. Now I have my function in a derivative-friendly form. So to take the derivative, I'm going to show you all the work here. I'll leave the 1 over root 3 out front. This pen is kind of tricky to write with here. Let me just clean that up here. Okay, we'll try that again. So I have 1 over root 3. I'll bring the 1/2 out front, and I'll subtract 1 from my exponent. Here, I'll bring the negative 1/2 out front, and negative 1/2 times negative 2 is going to be plus 1. You don't need to write the coefficient of 1, but you have to subtract 1 from the exponent to become negative 3 over 2, and the derivative of 6 is going to be 0. Just insert a new page here. To clean this up on the last, all I'm going to do is I'm going to multiply these two coefficients together. So my derivative now is going to be 1 over root 3 times 1/2 is going to be 1 over 2 root 3. My variable, or my term x to the negative 1/2 is not going to change. And my next term would be plus x to the negative 3/2. And that is one version of writing the solution. Now sometimes they'll move the negative exponents down to the bottom. All depends on what textbook you were using, but for now we'll just stop right there. Okay, let's take a look at another example. In this next example, you notice we have two terms in the numerator divided by one term in the denominator. So the first thing we need to do is get this in a derivative-friendly form. So I'm going to divide each term in the numerator by one term, or the term that's in the denominator. So we're going to split this up as follows. Now we're going to use our laws of exponents. Again, here, when my bases are the same, I subtract the exponents. So 2 subtract 4 is going to be x to the minus 2. Subtract, this should have been a 3 here, sorry. 3 divided, or subtract 4 is going to be 3x raised to the minus 1. Now I have this in a derivative-friendly form, and now I'm set to take the derivative. So f prime of x, again, the exponent comes out front, so it's negative 2. I subtract 1 from the exponent to become negative 3. The negative 1 comes out front, that's going to be plus 3x to the minus 2. And if we were to get rid of our negative exponents, you could write it as follows. It's supposed to be a plus sign, 3 all over x squared. And that would be your derivative, which represents the slope of the tangent line. All right, this next question is asking us to find coordinates. Okay, so we're trying to find the coordinates of 2 points on a graph at which the slope of the tangent line is 6. So they're giving us the slope of the tangent line, and so far in all the questions we've done, we've been given a function, asked to find the slope at a particular point. Now they're giving us the slope, and we have to work back to find the point where the slope is 6. So to start off with, as soon as you see slope of tangent line, you have to think of derivative. So the first thing I'm going to need to do is take the derivative of my function. And I will do that using the sum and difference rule. So the derivative of x cubed would be 3x squared. The derivative of 3x squared would be 6x. And the derivative of negative 3x would be negative 3. Now, we are told that the slope of the tangent line is 6. Well, remember, this right here represents the slope of the tangent line. So we know the slope of the tangent line is 6. So all I'm going to do is plug 6 into the derivative, into f prime, and my function on the right-hand side does not change. So now we're back to solving a quadratic equation. So, of course, we know we have to make that equal 0. And to make my math easier, I'll factor a 3 out, and I'll get x squared plus 2x minus 3. So this is 3. X squared plus 2x minus 3 will factor into x plus 3 times, let's try that again, x plus 3 times x minus 1. So therefore, either x equals negative 3 or x is going to be 1. Now Now those are just the x-coordinates of my point. So to find the y-coordinate, I always have to plug back into my original function. So I need to evaluate f of -3, which means I'm plugging -3 into my original function, which is right there. So it's going to be -3 cubed plus 3 times -3 squared minus 3, it should be a 3, minus 3 times -3. So this works out to be -27. -3 squared is 9 plus 3 is +27 plus 9. So this works out to be 9. So my first point where the slope of the tangent line is 6 would be -3 and 9. And now I do the same thing with the x-coordinate of 1. So f of 1 is going to be 1 cubed plus 3 times 1 squared minus 3 times 1. And this works out to be 1 plus 3 minus 3, which ends up being 1. So my second point is the point 1 and 1. So that would be the process we would use to find points where the slope is 6. All right, let's take a look at a similar example. So this one is saying, explain why a line with a slope of -2 could never be tangent to this curve. Well, again, as soon as you see the word tangent line or tangent, we're thinking derivative. So y prime, not sure why that's not working. Let me erase this here again. We'll try again. Y prime, if I take the derivative here, it would be x squared, because 3 times a third would be 1, and I subtract 1 from the exponent, and the derivative of x is just a coefficient in front of x, which is 1. Now, it's saying, explain why the slope could not be -2. Well, let's put -2 in as the slope, like we did in the last example, and we end up with -2 equaling x squared plus 1. And if I tried to solve this, I would subtract 1 to the other side, and I would get the following. X squared is equal to -3, and right away, bells and whistles should be going off, because if I tried to square root x squared, I could not square root a negative value on the left, so this is not possible. So therefore, it is not possible for a slope of -2 to be a slope of any tangent line on this curve. All right, last question says, the point on the equation y equals x squared plus 6x, find the point. So again, we're asked to find the point on this equation where this of x squared plus 6x, where the slope of the tangent line is parallel to the line 4x plus 2y equals 8. Okay, there's a lot of information provided here in this question, but the one thing you have to keep in mind, when you're asked to find the point where the tangent line has a slope, okay, if you're asked to find the point, they must be giving you the slope somewhere in the question. Okay, well, they say your tangent line is parallel to this line here. In order to find the slope of this line down here, I need to write it in the form y equals mx plus b. So therefore, I'm going to isolate y in this equation by subtracting the 4x to the other side. And I'm going to divide each term by 2. So I get -2x plus 4. So therefore, the slope of this line is equal to -2. Well, if my tangent line is parallel to this line, we know that parallel lines have the same slope, so therefore the slope of my tangent line is also going to be -2. Now, if I'm given the function and I want to find the slope of the tangent line from the function, to find a representation of that slope, I have to take the derivative. So using the sum and difference rule, the derivative is 2x plus 6. And now, The slope is -2, so I plug -2 into y prime, and I'm now going to solve for x. So I subtract 6 over to get -8, and divide both sides by 2, so the x coordinate, where my tangent line is -4. Now I don't just want the x coordinate, it says find the point. So to find the y coordinate, I just plug 4 into the original equation. So it's going to be 4 squared times 6 times 4, which is 16, plus 24, which is equal to 40. So therefore my point is going to be -4 and 40. That concludes today's lesson. There is your assignment. Again, check the web page for answers to that assignment. Good luck.